cofactors of the elements of the third column evaluate? You know, we can evaluate a determinant by multiplying each element of any one row or column with the corresponding cofactor and add. But this time, he wants you to do it with third column. So what will be the value of determinant? What are the elements of third column? What are the symbols? You write 1, 3, 2, 3, 3, 3. So it will be A13 into corresponding cofactor C13 plus A23 into C23 plus A33 into C33. So let us work out the value of C13, C23, C33 and then we'll substitute in 1. We already know the value A13, 23 and 33. The elements are YZ, ZX and XY respectively. Also note down the sign convention here, plus, minus, plus, minus, plus, minus, plus, minus, plus. That is for the third column, it will be plus, minus, plus. So let me work out C13 first of all, and with sign convention it will be plus times the corresponding cofactor. So 1, 3 element is YZ, you delete the row and column through YZ, you left with 1Y and 1Z, that is Z minus 1. So we have worked out C13 and now work out C23. Where do you have C23 element? This is C23 element, ZX. So delete the row and column through ZX. You left with 1X and 1Z. 1X, 1Z. 1X, 1Z. But what is the sign of 2, 3 element? It will be with negative sign. So it is negative times 1 into Z, that is Z minus X. And if you minus sign change the sign, it will become X minus Z. So the value of C23 is X minus Z. Now take finally the third one, C33. C33, again you delete the row and column through 33, and for 33 element it will be with the plus sign. That is, you delete the row and column through XY and you left with 1X, 1Y. 1X, 1Y. So you take the product, you get Y minus X. Y minus X. So now we have worked out all the three cofactors and let us multiply them with the corresponding C elements and we get the value of determinant. Let me write the formula again. A13, C13 plus A23, C23 and plus A33, C33. What is the value of A13? A13 is YZ multiplied by C13, which we worked out at Z minus Y. And what is the value of, I'll make a correction here, A23. What is the value of A23? ZX multiplied by C23, which is X minus Z. And what is the value of A33? It is XY. And we worked out C33 as Y minus X. Now, though we have got the answer, but you know it will be better. We are always supposed to give the answer in the most simplified form. So let us simplify, and I suppose it can be further factorized. And you will find a result. It is a cyclic result in 3 variables X, Y, Z. So it can be factorized. For that, let me first multiply. You get YZ square minus Y square Z plus ZX square minus Z square X plus XY square minus X square Y. Let us emphasize on Z. So you collect the coefficient of Z square, then that of Z square Z, and the third will be left. So if you take Z square common out of Z square terms, you get Z square times Y minus X. I mean this, and whereas here. So take Z square common, you get Y minus X. Then out of these two terms, you take Z common, and you left with, by taking Z common, you get see x square minus y square. And from rest of the two, what is common? You take xy common and you get y minus x. So what do you find now? That this y minus x is throughout common. You must be wondering, what about this term? So this has two vectors, x plus y and x minus y. Or better, if you take a minus sign common here. Just take one extra step. Z square times y minus x. Take a minus sign common to make it y square minus x square plus xy into y minus x. So now you have clearly two vectors, y minus x and y plus x. You may take y minus x common. Taking y minus x common throughout, you get z square minus z now. You know, minus z times, it will be y plus x or x plus y and plus xy, no doubt. Again open the brackets, you get y minus x is already out, and then you have z square, and multiplying with negative, you have negative zx, negative zy, and plus xy. It is easy to factorize the expression inside the bracket. From the first two terms, you take z common, you get z minus x, and from the last two terms, you take minus y common, so that we can again get z minus x. And now take z minus x common, you get z minus y. To make it in the cyclic order, out of y minus x, if we take a minus common, gives you x minus y. So x minus y, y minus z. So take a minus sign common here also, you get y minus z. So this minus and minus plus, and now we can write in cyclic order, that is x minus y, y minus z, z minus x. So this is the required value of determinant if we expand it along third column. If given is a determinant a11, a12, a13 and so on, the general notation for determinant of third order, and aij is cofactor of the small aij element, then what is the value of determinant? I discussed with you, the value of a determinant is obtained by multiplying the elements of any one row or column with the respective cofactors. That means, how do you work out which is the correct choice? That if you take a11, it should be c11, a12, c12. Whatever is the symbol for the element, same should be in the notation for cofactor. 1, 1, 1, 1, 2, 2, 2, 2, 3, like that. So what do you find here in the first part? In the first part it is a11, a31, it will not work. Then here a11, a11, alright. But here in the second term it is a11 and a21, this will not work. a21, a11, this will not work. So only the last choice is left, but then just see, you have a11 into capital A11, a21, capital A21, a31, capital. So what are 1, 1, 2, 1, 3, 1? These are the elements of what? First column. So it has been expanded with along first column. D is the correct choice.